Next is anisotropic and diastereotropic protons. In this lecture we will discuss anisotropic and diastereotropic. Anisomers are the organic compounds which are non-superimposable mirror image of each other. And diastereomers are the organic compound which are not the mirror image of each other. Or we generally said that diastereomers are the compound which are not enantiomers. So anisotropic protons or hydrogen atom if present in organic compound, they always give the same chemical shift. Means you can say they are equivalent. Anisotropic protons are equivalent. Diastereotropic protons, they are non-equivalent. So we will discuss some examples and suppose this is the compound with a chiral carbon, prochiral carbon you can say. There are two hydrogen attached here. So I will say these two hydrogen atoms, this one and this one, they are anisotropic protons. Anisotropic protons. And we said that these are equivalent. Now, how these are anisotropic proton? We just check it. We just replace the hydrogen by some other group. Like I am going to replace this by some other group, so the compound will form like this, Br, methyl here. Suppose I replace this proton with another group, that is Z. Okay, so this one isomer is formed. Now this carbon is chiral carbon. Okay. In a second, I am going to replace this hydrogen by Z. Then we get Z, C here, Br, methyl, and hydrogen this side. So see, these two are non-superimposable mirror image. It means these two protons, they are anisotropic protons because they give enantiomers. Now these two isomers, as both have the chiral carbon, these are enantiomers. What are enantiomers? The organic compounds which having a chiral carbon and which are non-superimposable mirror image of each other are called enantiomers. Out of these two, one will be dextrorotatory, other will be leorotatory. That you studied in stereochemistry. So these two protons which are connecting to this carbon is, you can say, a prochiral carbon. It's going to be chiral. It's not chiral in this compound. It's going to be chiral when you replace one hydrogen by some other group. So I place this group by Z, then replace this group by Z. When you get a two compound, and these two compound, they are mirror image of each other, they are non-superimposable mirror image of each other. It means we will say these compounds, this pair of compound are enantiomers. So that's why these two protons, they are called anisotropic protons. And anisotropic protons, they are equivalent. Okay. Then how many peaks this molecule will give? This molecule is nothing but just a ethyl bromide, you can see carefully. So it will give you 2 peaks. As these two protons which are connecting to Br, these are anisotropic protons. Because when you are replacing one out of these two, you will get an enantiomer. Either this or this, either dextrorotatory or leorotatory. So anisotropic protons are always give the same chemical shift and give only one NMR signal in the NMR spectrum. Okay. Next is we will discuss about the diastereotropic protons. Diastereotopic proton. What are diastereomers? Basically the compounds which are not the mirror image of each other. Suppose we have this structure. This is chloroethene or vinyl chloride, you can see. These two protons, this one and this one, these two protons are diastereotopic protons. And these protons, they give different peaks. It means these two protons, they are not equivalent. How we know that these protons are diastereotopic protons? Just replace it by some other group, just like the previous example. So when you replace it by some other group, you will get, suppose I am going to replace 1 by Z. You get this molecule. And second, if we are going to replace the second by Z, okay, you can write here is C, H. Okay, now I will replace this by Z. These two molecules, they are not the mirror image of each other. They are not a mirror image of each other. So what we call them, we can call them diastereomers. That's why these two protons, by replacing of which we get these two molecules, these two organic compounds which are not the mirror image of each other. So these are diastereomers. That's why these two protons are called diastereotopic protons, and they are not equivalent. They will give different peak. Then how many peak this molecule will give? This molecule will give A, B, C. We get 3 peaks. So, in the sum up, we will say that enantiotopic protons, they are equivalent, but diastereotopic protons, they are non-equivalent. Let's see one example here. Suppose we have a compound like CH3, CHCl, CH2, Cl. This is the organic compound. So how many peaks this compound will give? You will say 3. 1 by these 3 proton, 1 by this proton, and 2 by these 2 proton. But no. I will just opening the structure like this. C. Here we have a CHCl. Here we have a CHCl. See, there is one chiral carbon. This chiral carbon, and adjacent to this chiral carbon, these two protons, they are diastereotopic. These are diastereotopic protons. When you replace one out of these two, the second carbon also become chiral. But you will get diastereomers. You will get diastereomers. So it means these two protons adjacent to the chiral carbon, always the protons are diastereotopic. Keep in mind that when there is a chiral carbon in the compound and on the adjacent carbon there are 2 hydrogen atoms, so those 2 hydrogen atoms will be diastereotopic, and diastereotopic protons, we know that they are not equivalent. It means the total number of peaks given by this molecule, this 1 peak is given by these 3, 1 peak is given by this proton, 1 peak is given by this proton, 1 peak will be given by this proton, so we will get 4 peaks, not 3. This is the actual concept of diastereotopic protons and enantiotopic protons. In case there is any chiral carbon in the molecule, like in this case there is a chiral carbon in a compound, and And on the adjacent carbon, if there are two hydrogen, these two hydrogen, they are dash stereotopic. Because suppose the configuration of this is R. And when you replace the hydrogen by any other group, you will get different configuration. In one case you will get S, in another case you will get R. So then these two compounds will be dash stereomers. Means when you replace this hydrogen or this hydrogen by some other group, you will get two dash stereomers. That's why these are called dash stereotopic protons. And dash stereotopic protons are always non-equivalent. They will give the different peak. Okay, so this is a small concept of anisotropic protons and dash stereotopic protons. One more example is here. It's a cyclic compound here. We have a cyclic compound. This line bold means this is toward you, and the groups attached are, see, here we have a hydrogen, hydrogen, here we have a hydrogen, hydrogen, and here we have a methyl and hydrogen. This is the compound. Now we will find how many peaks this compound will give. Okay. Now see, this ring, three-membered ring, is in one plane. It's like this. This methyl group, this hydrogen, they are above the plane. This methyl group, this hydrogen and this hydrogen. This hydrogen, and this hydrogen, these are below the plane. First we will mark that this carbon which is present here, this carbon, these three protons will give one peak. Okay. Now this proton will give different peak because it is different connectivity as that of these four protons. They have different connectivity. On the transposition of this proton we have a methyl. Or you can say, if these two protons, they are different, you will write them C. Why they are different from these two protons? Because these two protons, they are with B. So like this B, this D, they are below the plane. Environment is different, you can see. This C and this methyl A, they are above the plane. And this B is exactly opposite to B. So connectivity of B is different. You can see here, connectivity of B is different. As B, on the opposite side of B there is methyl. No other hydrogen is there in which there is opposite methyl group present. So this B is different from A and C and D. So this molecule gives total 4 peaks. Okay. One more example is there, or the next example is, you can say, this molecule. This is ether. You will see this is a CH3, then we have a CH2, then we have a O, CH2, CH2, CH3. See carefully, all the protons, they are different. Their connectivity is totally different. You will see this methyl and this methyl, they are not equivalent. They are not equivalent. This methyl is connected to C, then O. This methyl is connected to C, then again C. They are not equivalent. So all the protons in this compound, they will give different peak. So this molecule gives 5 peaks. Okay, next is, see there is an example of H3C, this, and here again we have a methyl. At this carbon we have 2 hydrogen atoms, one above the plane, one below the plane. on this hydrogen and this carbon we have say one fluorine and one hydrogen. How many peaks this compound will give? Okay, see, this carbon is chiral, as connected to 4 different groups: fluorine, H, this side methyl, this side ethyl. You can see this group is nothing, is ethyl, it's methyl, it's hydrogen, is fluorine. It means this carbon, these 2 protons, they are stereotopic. If they are diastereotopic, they will give different peak. So then how many peaks this compound will give? This methyl and this methyl is also not equivalent. A, this will give B, C, D, E. So this compound gives 5 peaks. Again there is a diastereotopic proton, they will give different peak. Okay, if this compound is, I draw this compound like this. Here is a methyl, here is H, 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 H. Then how many peaks this compound will give? You will say there is no chiral carbon. These two proton equivalent. Okay, these 3 proton and these 3 proton, they are equivalent. These 2 proton and these 2 proton, they are equivalent. Actually they are anechotropic protons. When you replace any one out of these, you will get an enantiomer. First replace this one compound, then replace this second compound, compound 1 and second, they will be enantiomers. So they are anechotropic. These are anechotropic protons. These are also anechotropic protons. These anechotropic protons become diastereotopic when there is a chiral carbon adjacent to that. This is the concept only. Okay. Now this compound will give only 2 peaks. How to make these 2 protons? These 2 protons now are anechotropic. How to make an anechotropic proton diastereotopic? Just create a chiral carbon here. How to create? Just replace this hydrogen by fluorine, you get chiral carbon here. When this carbon become chiral, these 2 protons become diastereotopic. Otherwise they are anechotropic. Okay, so this is the overall concept of anechotropic and diastereotopic. These are the 2 problems. You have to find out the number of signals in the first compound and the second compound, and write in the comment box.